This segment deals with what's called disruption theory. This is something that was articulated by Clayton Christensen and Michael Raynor from Harvard Business School. First in a book which was called The Innovator's Dilemma, and then more recently in a book which was called The Innovator's Solution. There's been a couple of editions of that as it's updated over the years. Clayton Christensen has a really good philosophy about this, which is that he put this theory out into the market and then allowed people to come back at him with problems that they found, and as a result it's evolved a little bit. And there's some things going on around disruption theory which are really interesting. I should also say that there has been in the recent past some quite high profile criticism of this theory. And so if you are using it, you need to use it in an appropriate fashion. That debate is ongoing. I have not seen anything yet that convinces me that there's a problem. But in essence, the argument goes that a lot of the examples that Clayton Christensen and Michael Raynor used in their initial findings are of organizations which they claim were disrupted, and in fact, some of these organizations are around still today. And I think Clayton Christensen and Michael Raynor would legitimately argue that they may be around today, but they are in a completely different form compared to the way that they were years ago. So if you were to take IBM, for example, IBM was first of all in the punch card business when mainframe computers were all the rage, and then subsequently they moved into mini computers, the transition from the one to the other being a quite interesting story in its own right. And then subsequent to that they went into personal computers, and then they've been through services in the same way as Hewlett Packard have, and today within the last sort of 24 months or so, IBM have made in excess of $1 billion investment in Watson, which is the computer that competed and successfully beat all comers on the Jeopardy program in the US. So the Watson computer is about taking computing from the argument is that it used to be about ones and zeros, so kind of using a binary code to be able to program and provide solutions for things that could be codified and sequenced in a particular way. And then over time what's happened is that in the most recent manifestation, as is the case with Watson became as near as a computer has got so far to having a cognitive capability. In other words, it could actually learn. And a guy called Mike Roden was on a panel recently from IBM. He heads up the Watson group. And he was talking about the next step, which is about reasoning. So not only will the computer become cognitive, in other words, it can learn, but it can also reason, which is it can then start to work out what are the right kind of questions to ask. The learning process is about questions and answers, but the computer didn't know which questions to ask. So it evolved now to the point where the next phase is about this reasoning, and that apparently is already fairly mainstream in Watson's development. And they've created an ecosystem around the world. So if you look online, you'll find they're recruiting for Watson centers all over the world, even though they are headquartered in the US. So IBM has kind of evolved through these various different stages. But if you were to compare what a mainframe was capable of doing to what Watson can do, the only comparison is the fact that they are computers. The rest is they are completely different beasts altogether. So let's just talk. In order to understand this, I think we really do have to go back to basics. It's not popular amongst management and executive levels in organizations to learn theories, but in this particular case, this was probably one of the most important theories that's come to the market, as it were, in the recent past, and maybe for longer than that. And so you can decide whether you take it at face value or whether you can read something into it, and also you can decide you want to discard it and just ignore it. But let me take you through the way that he thought about this. So Christensen and Raynor talked about this notion that there's a level of performance that occurs over time. So if I was to put time on this graph here, and let's say performance over here, then what I could plot on this graph is what the expectation of a customer is, or put slightly differently, I could plot what it is that you as a customer could actually assimilate in terms of the amount of change that's introduced to a product or a service or a technology. So in order to do this, let's use this blue line. And this blue line we're going to say is the customer. Let's call that a change rate, if you like. So it's the rate of change that customers can absorb. The way that you can personalize this is you can imagine, if you use Microsoft's products, for example, you can think about every time Microsoft brings in an upgrade of their software, you have to kind of let go of the way you did things previously and learn a whole bunch of new things. And it's become a lot better over the most recent past. But for many years, from XP to Vista to the next, etc., all of these jumps were changed the software quite a lot. And so it improved it for many people, but actually it meant you had to learn quite a lot of new things. If you were to go from a fairly old banger motor car into a modern day motor car, you'd find that transition initially quite difficult because the instrumentation and the way in which it functions and operates is very different from what you used to have. So there's a rate at which we are comfortable to absorb the changes that come our way. The argument that Christensen introduced was, he said that in essence what happens is companies respond to what their customers say, and what that causes is, let's just say that when we introduce something, we introduce it at a level which is below what customers' performance expectations actually are. And if, for example, we had a call center or we have salespeople who are gathering data from customers, they would constantly be giving us input in terms of how to improve our products and services. And what we do is we feed that back into whichever the appropriate department is back at head office, if you like. And that could be into R&D, it could be into the innovation department, it could be into marketing, and so on. And what happens is we start improving our products and services over time. And eventually, our improvements start to reach a point where they match what customers' expectations actually are. Now, if that was the end of the story, that would be fine, because that mapping is an appropriate mapping. But in fact, what happens is we are driven to continue up the same trajectory of innovation by all sorts of things. Customers continue to look for different things. So, for example, if I have two different customers, one customer represents this view, another customer has a specialized use, and so on. They move us up the curve. It could be competitors that are introducing functionality in competing products, and we have to try and remain on par with them. It could be our supply chain is actually delivering improvements in the input side of our products and services, and for that reason they move us up. But whatever the case, we continue to move up this trajectory. And Christensen talked about this idea that this you could call a sustaining trajectory of innovation. And typically, if you're an incumbent, in other words, you're already in the market, this is the focus of your attention. So if you already manufacture computers, you try and make them brighter, faster, longer battery life, more memory, etc. and so forth, perhaps better design and so on. But in essence, what you're doing is you're moving up that sustaining trajectory. And you can have small steps, which are the so-called incremental innovations, and you can have bigger steps, which are the so-called radical innovations. So we talk about degrees of innovation. So small steps, incremental, big steps, radical. But the thing to notice is that you can be taking quite big bets, but on the same trajectory of operation. Now, if I was a manufacturer of horse and buggies, and I want to improve my product to my customer, I may, over time, I may improve the wheels, I might improve the suspension, I might introduce some kind of braking mechanism, I might change the configuration in terms of making it appropriate for high speed or low speed buggy that's attached to a horse and so on. But what I'm not doing is I'm not moving away from this sustaining trajectory to something which might be like, for example, an automobile. So someone introduces something on a different trajectory here. This could be disruptive to the horse and buggy industry. And when they first introduce those things, They might be slower, the automobile that is. They will be considered to be noisy, they're considered to be dangerous, they are considered to be basically a nuisance. Why? Because people will tend to want to stick with the sustaining perspective. So this second curve, perhaps I can, I'll write it in black here, but this is the so-called disruptive curve, or disruptive trajectory.